Alrighty guys, welcome back. Today we're going to be talking about factoring complex trinomials. And let me write that down. Now, as you probably remember, trinomials are normally written in this form, where I have ax squared plus bx plus c. Okay, where a, b, and c are any number, right? Any integer. So, last time with factoring simple trinomials, if you watch that video, I talked about how to factor it when a is just 1. But the issue is, a lot of times, a is not 1. So what is going to happen is this. It's going to be a little bit different. We're going to do some things similar to factoring when it is a simple trinomial, but also some different things when it is a complex trinomial. So first off, we are going to use a similar format. Okay? First thing I'm going to do is off on the side, I'm actually going to do a times c. I'm going to multiply those two numbers together to get some number. Okay? Then I am going to do that same hourglass method, but I am going to do it with the a times c number, and I need two numbers that multiply to that, and it needs to add to the number b in the middle. Okay, so one of the extra steps I'm adding is I need to multiply the first number and the second number. And similar to last time, let's say I get a p and a q as my answer for whatever happens. What I'm going to do with them is going to be a little bit different than last time. Last time we just threw them into factors and called it good. This time we have to organize it and write it out a little bit differently. So I'm going to get p and q, but I'm going to rewrite my polynomial like this, where I am going to split the middle term into p times x plus q times x. Or if they're minus, it could be like negative qx minus px. However you want. As long as you keep them straight, you are good to go. And again, like q can go where p is, p can go where q is. As long as you separate it into two terms, you are good to go. Okay? Then the next step you are going to do is you are going to then factor by grouping. And if you forget how to factor by grouping, I would highly recommend going and checking out the previous video. But what I do for factoring by grouping is I split this in half and I factor each part, look for a similar thing, and then combine them together. So in the end, I will most likely be getting an answer that looks something like this, where I get like 3x plus 4 times 2x plus 8, or something like that. That could be the answers that it factors into. Okay? So I know I just explained it theoretically. Now I'm going to walk through an example so you can see how it actually factors out and how it actually works out. So I have an example question of 6x squared plus 11x plus 3. Okay? So first thing I'm going to do, I'm going to take the first number times the last number. So I'm going to do 6 times 3, which is 18. Okay? Then I am going to take this 18 and 11, because that's my b, And now I need to think real hard. I need to think of numbers that multiply to 18, but add to 11. So the numbers that multiply to 18 are 1 and 18, 3 and 6, 2 and 9. I'm trying to think of any other ones, but I currently can't. But going through those, 18 plus 1 is 19. 2 plus 9 is 11. 3 plus 6 is 9. So it will have to be that 2, those 2 and 9, those numbers there. Now I'm going to take those two numbers and I'm going to rewrite the trinomial separated out. Okay, so I'm going to have 6x squared plus 2x plus 9x plus 3. Okay? Then I'm going to factor by grouping, where I split it in half and I look for the greatest common factor between the two of them. So first off, looking at this half over here, I have 6x squared plus 2x. The greatest common factor between them, if you want to think about it, feel free to pause the video, but the greatest common factor between them is a 2 and an x. Then, once I've determined the greatest common factor, I then decide, hey, what do I need to multiply 2x by in order to get back to 6x squared? In this case, I need to multiply 2 by 3 to get 6, and I need to multiply x by itself to get x squared, and then 2x is just that, so I would multiply it by 1. Okay, do not just leave it as 3x. It completely changes the problem, so make sure you add that placeholder of plus 1. Okay, now I'm going to look at 9x plus 3, and hopefully you can pause the video and identify the greatest common factor, which in this case is 3. Okay, so 3 times what gives me 9? 3, and there's an x. 3 times what gives me 3? 1. So now I have it factored out like this, but I need to take another step. Okay, I have it partially factored by grouping. I need to fully factor it by grouping. So because these two parentheses are the same, I can rewrite it down below. I'm going to write it in the original color. I can rewrite it down below, and I'm only going to write it once down below. Now, because these are multiplying these same parentheses, I can then take them and combine them into some parentheses together. Then I double check the parentheses. Is there any more factoring that needs to be done? No, I am good. Okay, there is no other greatest common factor between any of these guys. There's nothing else that can be factored, so I will leave it as is. Okay, so hopefully that was a detailed enough explanation of what to do and how to factor when you have a complex trinomial. Well, thanks for watching.